So hello guys, this is one of the questions that's going to be perhaps going to be in your exam. So this question is asking about the change in energy for the bond, and we have to use a table. So you guys will see a table, this like a table like this, right? And you guys have to figure out the change in energy type of thing. So I'll show you how to do this question. But even before attempting to do this question, you guys have to know how to make a Lewis structure, where to find the valence electron in the periodic table and whatnot. But for now, I'll just tell you what it is. For instance, so in the periodic table, if the periodic table is here somewhere, I'm just making a little chart. C is here, so 1, 2, 3, 4. So this is gonna have four valence electron, right? So, and this is a composite compound. We learned this in the last lecture as well. But the way I saw so many of you guys, so let's say if you guys are making a Lewis structure, you guys, let's say for instance, you do like H2O, you guys instantly just do this. But in the process, you guys forget about the lone pairs on top, right? But this is not the right way to make the bonds and Lewis structure, right? So we have in oxygen we have six valence electron, right? So 1, 2, 3, 4, 5, 6, right? And we have one valence electron in hydrogen, right? So that's how you connect the hydrogen atoms with oxygen, and that's how you form the bonds, right? So we have these kind of lone pairs on top, but a lot of you guys are not doing that. So, but that's a very bad habit, and I would suggest you guys relearn how to make a Lewis structure and stuff like that. But getting back to this question, getting back to this question, getting back to this question. So we have to find the change of energy between the bond and from the table, right? So firstly, we have to make a Lewis structure of the composite compound. So this is going to be, so valence electron for C for carbon is 4, right? So we have to make 1, 2, 3, 4. And the way you connect this is we have 3 hydrogen, right? So we can connect. The reason why we put C in the middle is because this is the most amount of electronegativity in this compound, right? So we have 3H, 3 of H, right? So we can connect it like this, we can connect it like this, and we can connect it like this. And we have to connect C with C, right? Okay, so this is the product. And this is forming this compound, right? The reactant with this H2 as well. So let me erase this real quick so you guys have kind of an idea of what to do. All right, so this is going to be like, this is forming to be there's a bond, two bonded pairs. So it's gonna be like C to C and two hydrogens here. So it's gonna be like this. And there's a separated two of H. So two of hydrogen models is dancing over here. Okay, so it's gonna be connecting like this, bond pairs. Keep in mind, these are not bonded together, but these are. So the formula for this reactant, right? The formula for this question is bond broken minus bond form, right? So basically this question is saying we have to indicate what is a broken bond from here to there, right? So when you go from here to there, what is being broken and what is being formed, right? So from here to make the to make the double bound, we have to break this, right? we have to break the single bond here. And to make a single bond of H over here, we have to break these two, right? So otherwise it's not going to work the same. So this is basically the same. So these two are being broken. So what we have left here is these, right? So this is basically the same, and this is basically the same, these kind of bonds. So we have to calculate the energy of the broken bonds with the bond being formed. So here we have the bond being formed. I'll just make a little chart. So we have C to C, the things that's being broken, this one, C to C. And the energy is, this is the energy that I got from the table, is 346. And the under the bond that was broken was C to H, right? That was 411. And another bond that was broken was C to H again. The bond being, what is being broken here is getting formed here, right? So we have a double bond being formed here, carbon to carbon, right? And the energy for that was 432, and another bond being made over here, right? And for the energy was that for, oh no, okay, I mixed it up. So energy for this was 432, and the energy for carbon to carbon was 602. Right, so we basically add all these up, the broken bonds. So plus 411 plus 411, and we have 11.68 minus 602 minus 432. So let's calculate that real quick. So 1168 minus 1032. The answer, the change in was it? Yeah, the bond energies is 136. Okay, I'm gonna do another question in person, but I want you guys to just take a look at this video, right? It's gonna be in the lecture slides as well, and just figure out, like, just do a basic problem like this. All right, thank you.